Thank you everyone who's joining. We're just going to take a couple minutes to get set up here. Phil, are you just Phil in the chat?
I'm just Phil.
Okay.
Maybe.
There you go. All right, so we're at 38, 39, so we'll give everyone else a couple more minutes to get on here. Thank you everyone who's joined so far. I'm going to start the screen share.
Yeah, I'd say for the last workshop, most people joined about 4 to 5 minutes after the fact, so you might just give it a few more minutes.
If you guys, so Eli, if you could just one more time distribute the RStudio Cloud links. If you are planning to participate in the coding exercises today and all of that fun stuff that we're going to cover within the workshop, you should have received an invitation from RStudio Cloud. So just check your email for that. I'll restate this a couple more times as people get signed on here. But that will give you access to the RStudio Cloud environment that we'll be working in today.
I will do that. It looks like there are a few people who haven't accepted the invitation yet. If you haven't gotten any email at all, feel free to send me a message in Slack or in Zoom, and I'll get that out to you.
Other thing I was going to say here, Mike, was that if they go into RStudio Cloud, it can be a little bit tricky. In the left-hand side, they should be able to find a link to the space that you've set up for today. And so I don't know if you have to actually give them the link directly. Let me give me 2 seconds, okay. And I'll send a bit of info through the chat box.
Sure.
Here's what they need to do. So so it's not too much. It's just navigate to the workspace from the left sidebar, and then from there they should be able to see the space that you invited them to, and then they should be able to click on that and jump into the environment. And then the first time you launch it, it should take 20 or 30 seconds, maybe a minute at the most. And then you should be good to go with the live environment.
Okay, and I'll walk through that as we go through the setup again. We'll give one more minute. We're at 54. Just give it a couple, or one more minute to get everyone set up and in here, and then we'll get started. All right, we're pretty stable at 54, so I think I'll kick it off here. Just let me get my deck going. This annoying thing that I always got to do. All right, so hello and welcome everyone. Our workshop today is called Multilingual Markdown with R and Python using Reticulate. So today, the team that we have here that's going to help you through this workshop is myself, Mike Stackhouse, Nathan Kosiba, and Eli Miller. We're all from Atorus, and Phil Bowser is also going to do some presentation, and he's here to help out as we go through the workshop portions of this today. But yeah, so getting started. You should have received an email beforehand. One thing that I do want to point out is that I have some links within the slide deck, and as we're going through and moving, there's a lot of material that's covered within the slide deck. So in the email sent out to all of the attendees beforehand, there's a link into the GitHub repository and a link to the RStudio Cloud instance. Those are things that you're going to want to make sure that you can access. In the GitHub, I have a link there as well to download the slide deck. If you download for that self and have it open so you can go along, I recommend that you have that open on your desktop so that you can access the materials and refer back to things as we move past it. But looking at the agenda today, we're going to go through the introduction and getting everything set up within RStudio Cloud so that your environments are ready to go. Phil is going to walk us through some of the backstory behind why we wanted to do this workshop and talk about R and Python together and the environments and ecosystems that you can use these things. We're going to go over the motivation of the workshop and the structure within the introduction. We're going to break this down into 4 different pieces. So we have 4 different sections. We're going to learn a little, and then we're going to go into breakout sections. Within these breakouts, you're going to have coding exercises within sections of the materials that we've provided that you can go, you can work through, and that you can do some coding yourself. So section 1, we're going to work through the introduction to Reticulate and getting Reticulate set up within your environment. We're going to go over capturing information in Python. And accessing that information from R. And then we're going to do a 15-minute breakout. In section 2, we're going to talk about reading data in Python, and we're going to go over list comprehensions, which is a tool in Python that you're going to that's very useful. And then we're going to do a 20-minute breakout. In section 3, we're going to talk about conditional markdown syntax and the handoff of data frames between Pandas data frames in Python and R, and do another 20-minute breakout. And in the last section, we're going to cover the with statement and context managers in Python and talk about parsing text files in Python and do one last breakout. So we're covering a good bit of material. So what you'll learn today and what we hope that you can take away from this, we're going to do a bit of Python and a bit of R. We're not going to dive too deep into technical aspects of either because the focus of what we're going to be talking about today is how you can use these 2 tools together in the same environment in the context of an R Markdown document. So we're going to go over how to set up Reticulate and how to use it within R Markdown. And how you can use these tools together to really get the value of both languages and what they have to offer and see how you can reap those benefits. And ultimately what we want to talk about today is how you can take this home and use it in your processes today. So again, hopefully you can get access to the slide deck. The GitHub link is right there. So it's github.com/Atorus-research/multilingual markdown. You can get the slide deck here. You can download that directly from GitHub. I think that it's worth showing that to you so that we can walk through that. So if you get into the GitHub page and then you click on the .pptx file, there's a download button right here. So you can get the slide deck down onto your machine and you can open that for yourself. And then you'll be able to follow along outside of the slides that I'm sharing on my machine itself.
Hey, Mike, just before people jump into RStudio Cloud, one thing you might do is actually go in and make the space that you have an assignment. And the reason that would be good if you haven't already done it is it will make all of the projects that come from your space permanent projects, so they won't be temporary. So I'm not sure if you've done that, but I just remembered we had to do that for the TensorFlow workshop just before this.
Okay, I did that on my own, but are you suggesting that everyone does that?
No. If you did that as like the master owner, then everybody else will be good. It just basically saves them the effort of having to save it as a permanent project. So good job.
Okay.
Yeah, good stuff.
I did read your email.
Okay, good. No worries, man.
So yes, that's already done. But yeah, so that the RStudio Cloud link is here. You've been invited, but if you log in, like Phil was saying, if you log into RStudio Cloud and you come over, where are you? Right here. So over on the left tab here, after you log in, since you were invited, and just make sure that you're using the same email account that you registered for R and Pharma with, as that's where the email or the invitation was distributed to, you'll have this multilingual markdown workspace that we have set up. The template project is labeled assignment, like Phil was saying. So you're going to want to click this. If you clicked new project, don't worry about it. We're going to need to go through some of the same setup process, and I did make the GitHub repository linked with the base project that new projects start from, so that's fine. And we're going to go through that whole setup process, but you're going to want to come into the template project that we have set up here. It'll create a new one for yourself. That's just a copy of what I've made available. Back here, and I'm just not going to go to presenter view. So we have the RStudio Cloud environment and we have the GitHub environment. Just make sure that you have these two things. If you didn't receive an invitation, send it to the chat, and Eli will get that invitation set up for you. So moving forward, so all users, again, just restating that, check your email if you didn't get the invite. But once you come in here, if you click on the assignment and get your template project set up, the first thing that I want you to do is on the Git tab, click Pool. So if I come in here, the Git tab is right here. And then the Pool button is this little blue button. I want you to click that. We've been updating the repository and just making sure that everything's polished and ready for you today. And then you'll get some feedback like this of just all the updates that have been made, and that will bring everything that's current in the Git repository there for you. So just that's the first thing that we needed to do before anything else happens. So hopefully you're following along, but the next step I want you all to do right now, because we do have a number of installation pieces that we need to run today. So what you're going to do is open the terminal, not the console, and run the command bash./setup. I'm going to do that right here. The terminal is in this bottom left box. You're going to click on the terminal, and then I'll bring up this command line that you see here. It'll have /cloud/project. And then you're going to type bash space ./setup.sh. So this is really important for everything that you're going to be doing today. So if you plan to participate in the coding assignments, please make sure you do this. So you're going to execute that, and then you're going to start getting a ton of stuff outputting on your terminal. Just to walk through a few of the things that this is going to do, it's going to install Miniconda, which gives us the latest version of Python. It's going to install the Pandas library and get that all set up so that we're going to be using a modern version of Python with Reticulate. And then it's going to install a number of R packages that are going to be necessary to work with Reticulate and all of the R Markdown stuff that we're doing today. So at this point, this is going to take a little while to run. So just get that set up and get that running because we're going to switch over and Phil's going to present for us. And all the setup is going to run so that hopefully once Phil's done and we jump back in and get into the first breakout, by that point, everything's installed for you. But there's no input needed from you. It's going to do everything for you, so don't worry about it. It's just all you got to do is get to the terminal. And within that, type bash space ./setup.sh. Again, that's in the slides, so you have that there. But get all of that running. And like Frank said in the chat, I put that, what you need to type into the chat of the Zoom. So look there and you'll have the command that you need to run, and then you can just copy and paste that as well. But if you have any, thank you, Paulo, for sending that link. Very good idea there. I don't know why I didn't think of that. So get into the GitHub, get all that pooled, and get the setup command run. If you have any issues with that, post something in the chat. Good question, Yafeng. So this will not work on your local machine. I do have this set up to make sure that everything installs in the RStudio Cloud environment. If you're working on your local machine, we can help you through a few pieces of this, but you're just going to want to make sure that you have a modern version of Python, Pandas installed, and then there's another script in here that you can run just to make sure that you have all the R packages, install package or pkgs.r, and just make sure that's installed. And that you have a modern version of Python, something like the Anaconda distribution. But we're going to go through setting up Reticulate later so that you know how to use that with the how to get Reticulate to point to the Python installation. So we'll cover those pieces in a bit. So at this point, I'm going to hand it over to you, Phil, so that you can talk for a little bit. If you have any issues while Phil is talking, post them in the chat, and we can try to get you a little help here. So I'm going to stop the share and hand it over to you.
Thank you, Mike. The one thing that I would say is that if you get an invite, let us know and just message us privately. We just need to add you to the space. I just had a few people message me individually, and I just added them, so I think they should be good. But all right, so what I want to do here today is just set some context and some background. Really, all of this started back around 2016, 2017. When the deep learning space was really taking off. And we had this perfect situation that really came together where we had just the hardware that was available. And I'm sure many of you have heard of NVIDIA, especially with their stock soaring as of lately in the gaming industry, right? That was really helping to feed that. We also had data sets that was fueled by the internet that was coming available and provided us the data that a lot of these deep learning models needed. And we also had just a wonderful advancement in the algorithms, gradient propagation, for example, and especially thank you to Bell Labs for all the work that they did for the last 30, 40 years to put into this space. And so all of a sudden, the deep learning space had exactly really what they needed to finally take advantage of some of these, and some of the tournaments and things that were out there, the deep learning models were just winning and dominating the space. And I think finally people saw a lot of potential in this, rather than what had happened kind of in the 80s and the 90s. And what was interesting though is Google got into the game and they created this space called TensorFlow. And when they open sourced it, they provided the bindings to it via Python. Well, not in R. And so back in 2016, 2017, the R community was like, well, what the heck? How do we tap into this space, right? So JJ Allaire, our founder of our studio, went to work and he wrote the bindings into TensorFlow. He worked with the author of the Keras package. And so if he came from the workshop before this is really what came first. And it's almost a little silly that it came first, because you would think first you would have the bindings into Python and then into TensorFlow, but really the use case was making sure that this story was solid. And then after that, they had done the work to connect to TensorFlow, so they just went ahead and did that for Python, and they created a package called Reticulate, which we're going to look at today. But if you haven't seen this keynote, I think it's really, really phenomenal. And so what I did this year, even though the conference went virtual right during the March timeframe, is that Fuse, I had two papers there. One was, really this idea of Python for clinical workflows. And then the other one was talking about this space of TensorFlow and deep learning that was growing in this space. And so I put together a paper called R and Python for Clinical Workflows. And really what the paper does is simply just kind of take you through the timeline of how these things have come together. And so if you're new to this space, or especially if you're like from R and you're kind of wondering how Python has come into this world, or how the interoperability of these languages work together, I think this is a good paper that will take you through some of this. I'm just going to highlight a couple things for you quickly. R and Python are, at the end of the day, different languages, right? Python is a general purpose programming language. R is an awesome statistical programming language, and is a nice fit for a lot of people coming from that world of SAS and statistical programming. And then really what we're going to focus on today was that in 2015, the R Markdown toolset added Python as a language engine. And so what that basically means, if you can see my screen here, you can now run Python inside of R Markdown, as well as other languages like SAS. I think Julie is there, Stan, and other languages. So that was a really awesome thing that happened in 2015. Jupyter then also added support for R around that time. And so if you keep going down, like what ended up coming out was Feather, which was a package to help with the interoperability between R and Python for data frames. The R notebooks came out in 2016, and this was really because of the popularity, I would say, to a large degree, of notebooks in the data science space, mainly being led by Jupyter Notebooks in the Python world. I mean, and if you keep going, finally in 2017, we had Reticulate. And the key word that I want you to take away from Reticulate is interoperability. And so what really is great about that is that now you had this language or this package that let you handle well the connecting both the R and the Python, excuse me, my calendar's going crazy, the R and Python ecosystem. And so what could happen now is you can have data scientists that know Python, and you as an R programmer can bring that into your workflow, or you could also take R to those Python programmers, because now, as you'll see in today's workshop, you can take these objects and these variables and you can pass them back and forth. And that was just an amazing thing, as well as you can call and incorporate Python directly inside of using the Reticulate R package, which was the language that came out of the work, as I mentioned at the beginning, around TensorFlow. And so this paper then kind of goes into the Apache Arrow project, Ursa Lab, how they're working on something similar, the updates to Reticulate. So I'll share this in the chat box, but it does a good job, I think, of providing some background into this space. And I think a lot of this has been evolving and growing. So even last year, the same people that helped to put on R and Pharma, especially the Roche group, they helped to support a conference there in Basel, Python and Pharma. Right. And I thought this was a really, really interesting thing. But the one thing that really jumped out to me, especially for the clinical space, was the word clinical shows up on the entire program one time. Right. So it's really something that's exciting for clinical. And I've noticed, I've been teaching a workshop in the clinical statistical programming space for now 5-6 years. And I noticed about 2 years ago, a ton of questions and comments and requests for adding Python to that workflow. And now that we have Reticulate and like this workshop, we can do something like that. And so that's why I went to Mike and I said, hey, I think there's a big opportunity to help, bring Python and teach people about this into this ecosystem. And it will be interesting to see, especially I suspect many of you are sitting there in the clinical world, how this will impact things. And so, I reached out to Mike because back in 2000, I think it was 18, maybe even further back, I saw that he gave a talk at Pharma SUG talking about simplifying and streamlining using Python. And I remember I went up to him and I said, hey man, we need to sync up, team up, and there's probably ways that we can work together, because he was at these clinical conferences like Fuse and Pharma SUG talking about Python, and I was there talking about R, but I could see these worlds coming together, and that this data science toolbox had some really awesome tools like R, like Python, like Julia, like Stan, C++, and so on. And so I don't think it's really just a matter of having one language. And I'm sure all of you here can remember back to the 2017, 2018 timeframe where it was all about the Python and R wars. I think that game is over, right? It's not about should I use Python or should I use R. The answer is I should use both. And when should I use these in my workflows? And so that's really what I liked about what Mike was doing. And then I saw this year too, he gave a talk again at Pharma SUG talking about Python. And so the key thing that you'll start to see here though is that his talk was about doing automation, and the person before him talked about using Python to automate. So it's going to be interesting. It's like maybe in the clinical space, maybe automation is how this, where this goes towards, or is it going to be more tapping into the data science space that grows in clinical? I don't know if anybody knows exactly right now, but it's going to be exciting to watch. And I think workshops like today are important to help give you the tooling and the understanding of this space to help bring some of these things together. So it'll be interesting to see in the next few years really where this goes. But what's also interesting to me is that there's a ton of different ways to bring this ecosystem together, right? You can do it through Jupyter Notebooks directly. You can do things like write APIs with Flask. You can start to create different artifacts like Shiny applications, but in the Python space like Dash. You can use our Markdown with Python like we're going to look at today. You can use Shiny with Python. You can use Python with Plumber. So I met with a group once who had spent a lot of money putting together a Python API and deploying that. It was calling out to R and doing some other stuff. And they didn't even realize that there was packages in R like Plumber that could do that. So there's, really trying to bridge the Python and R community is a big thing right now. And so there's a lot of good examples like this that I'm happy to share with, but I think this slide really kind of highlights all of it. This is a really rapidly growing and evolving space, right? And is the answer or the future going to be coming to Python directly and creating tools like this, or is it going to be using R to translate into Python, just like really tapping into the legacy of R, even back to its Bell Labs days as S. I mean, it was simply an interface into Fortran and C++ or C libraries. And now, you take it forward, maybe tools like Reticulate being the bridge between the two really will be a big part of this. But time will tell. So hopefully this gives you a little bit of background and why I bugged Mike to put this content together, because I think it's going to be exciting for the community and see where we take this forward. And then maybe the next Python or in Pharma conference, there'll be 5-10 different talks in the clinical space, and will be exciting to see how this grows. So with Mike, with that, man, I'll pass it back to you to take this puppy over, and I'll share some of these links in the chat group for people that are interested.
Awesome. Thank you, Phil.
And hopefully the install script is done at this point.
Yeah, if you have had any issues with that, please reach out to Eli or Nathan, as I'll be presenting. So you in Zoom, you are able to use the chat window and IM people directly, so you can use that as your forum, or you can, there should be a button to raise your hand somewhere. I'm a presenter and a host, so I don't know that that's there for me. But find your way around, poke Nathan, Eli, or Phil, and they can help get you set up and running here. But with that, oh, and Nathan's going to be presenting too. So poke Eli. Eli will help you out.
I was like, I have speaking parts.
Yeah. All right, so section 1. So this is going to be the first piece that we cover and leading up to our first breakout. So this is going to cover the use case, the setup, and the basics of where we're going to get started here. So the objective of the workshop today, and this kind of ties in with some of the things that Phil, thanks, Nathan. This covers some of the things that, some of the concepts that Phil's talking about with the talks that you see out here. And it's one of the things that I feel fairly strongly about when I go out and I talk about Python and I talk about R, is that not everything needs to be within the context of the study analysis. There's a lot of things that these tools can do for us on the edge cases and the other pieces of things that we do on a daily basis to make our lives easier. And Python particularly, I love for automation tasks. It's a really great language that you can rapidly build tools that can do a lot for you. So what we're going to do today is focus on study closeout compliance checks. So this is something that I've seen a number of different versions for, and I'm sure a lot of you have different tools written in SAS or shell scripts or what have you in your own companies. But when you wrap up a study and you are getting ready to get the submission out and you need to make sure that everything's good to go, you might have different reports that run to make sure that everything is ready, everything is meeting what's in your SOPs, etc. So the two things that we're going to look at are directory checks and file checks. So when I talk about directory checks, after you finish up a study, you probably need to do some study closeout. You need to do some cleaning to make sure that there's no trash hanging around, that the programs are all good to go, that everything exists that should, and that the files meet some requirements. So you might have a log checker or stuff like that. So we're going to go over some. We basically broke this down to what do we think that we can teach you in 3 hours. So it's not going to be a full-fledged and meticulous check, but we're going to show you some concepts of how we can do this. So for the directory checks, the question is, do all programs exist that should? Do all outputs exist that should? And is there any cleanup within the directories that needs to be done? Similarly, on the file checks, we're going to show you how to open up a file in Python, and the specific check that we're going to do for parsing the text files is we have a set of RTFs, RTF outputs, and we're going to look at that, and we're going to check the RTF file to see if the source file line in the footnote of the table is correct. That's a very rudimentary approach that we're going to teach you, but we're essentially trying to see, do you have a footnote in the file that has the directory path of the program that should have produced that file. So basic things that we're going to cover, but we're going to show you how to use Python to do some of this automation. We're going to use our Markdown to create the report, and we're going to use Reticulate to make those two languages talk. So there are a few Python libraries that I'm going to highlight. I'm not going to highlight the R packages because we're this is R in Pharma, so I'm going to introduce you to a little bit more of the Python pieces that we're touching. So there's three libraries that we're using today that I want to highlight, and that's OS. So this is going to do your operating system level interaction, and we're going to use this to interact with your directories and all of that fun stuff. We're going to use the RE library, which is for regular expressions. We're going to use very basic aspects of this, but we're going to use it to run simple searches for substrings within either a string that we pulled or for searching the file that we're going to read in. And we're going to use Pandas. If you've followed Python for data science, Pandas is one of the biggest libraries out there. This is what brought data frames into Python. We're going to use that to read a metadata file. We've built a CSV file for you. And we're going to iterate operations over the rows of that file, and we're going to collect some new data along the way that we're going to be reporting. And we're also going to show you how these things hand off between R and Python, and how it's really simple to take a data frame that you built in Python and then convert that into a data frame in R and use it directly. So the first question that you need to ask yourself when you're going to use Reticulate is, where's my Python? So question one is, which versions of Python do you have on your system, and what version of Python do you want to use? So if we go into RStudio Cloud, this is something that I would do on the terminal. And there's a command in Linux called which, and then if you search a command that you want to use, it'll tell you where that file is. So which Python returns user bin Python, and if you use the Python command, that will come up for you, and you can see that the default Python installation that we have on here is version 2.7.12. So it's important to understand what you have available. On Linux systems, right now, modern systems are going to come with two versions of Python. That's going to be Python, there's going to be a Python 2 version, and you're also probably going to have a Python 3 version. So if I use the command which Python 3, you can see that we have a Python 3 executable here. And if I use that Python command again, you're going to see that we have 3.5.2. So that's better. So we have version 3, but today what we're going to be using is the Miniconda installation. So if you're familiar with Python at all in a data science context, the typical go-to that you're going to want to pull for a distribution of Python is going to be the Anaconda distribution. And Anaconda comes kind of pre-packaged with a lot of data science packages ready to go. Miniconda is just a much more lightweight installation that it's going to come with just the very necessary libraries, and it's going to come with the Python distribution itself. And that's going to, with the install script that we have here, is going to be within your home directory, and we have Miniconda bin Python. And here we installed for you Python 3.8.3, and you can see that it's the Anaconda distribution. So Anaconda comes with a package manager for it that helps with all the version dependencies in the data science world. You don't really need to concern yourself much with that at the moment, but we pulled this because it's a modern version of Python. And there's new features coming out in these later versions, and we installed Pandas for you, which depends on 3.6 and higher at the moment. And that's going to give you some more modern tools to work with. You might not be able to do this within your organization, so we're not going to cover it today, but there's still a lot that you can do, even going back to version 2 within these automation tasks. Instead of using Pandas to read data frames, you can use the CSV library, and you can still pack a lot of power into it. It's harder, but it's still doable. I've done it, and so there's still a lot that you're able to do with that. And you don't need to worry about setting this up because, as I mentioned in the beginning, we did set Reticulate up for you. within all of this. So you're not going to have to configure that, but we're going to go over how. So one of the first questions that you should be asking yourself is what versions do you have access to in your system? And if you have a Linux system, you probably do have Python available unless IT specifically removed it. And which do you want to use? So question 2 is which version should you use? And like I mentioned, is it available system-wide? You don't want to be producing tools that are installed within your home directory on Linux. If it's something that you're going to deploy to a larger group, you need to make sure that that version of the language is available. And then it's worth asking if your IT group can install a new distribution. That's something that I've been able to get done in the past and get the Anaconda distribution installed on your system. And one of the things that I mentioned here is there's a lot of these tangential side processes that you might want to automate that aren't part of your statistical analysis. So you're not going to need to necessarily worry about all of that qualification effort and the validation because the tools that you're producing are validatable themselves. So that's one of the points about what we're producing today. If you build a process like this, you can also validate the process following whatever qualification process you have within your organization. So it's worth asking, can your IT group install a new distribution? If you have a version on your system like Python 3, that's great. If you have 2.7, there's still a lot that's useful in that. If you're stuck in 2.6, I'm sorry. It's still usable, but it just gets a lot harder. I've had to rely on version 2.6 and just, it's not as fun, but it's still usable, but that can just be painful. So with this, I'm going to hand it over to Nathan, and Nathan's going to talk a little bit about setting up Reticulate.
So Reticulate is this engine that lets Python and R talk to each other, not just in R Markdown, but it can talk to each other through normal R scripts as well. Reticulate, the keyword, I believe, is interoperability. That's what Phil really likes to pump up about it. But it basically means that it can talk to each other. You can hand off objects between like variables, data frames between each. And it's actually really cool. You can do a lot with it. We'll get more into it through the workshop. Of course, this is a big reason why we did it. There's a lot of ways you could use Reticulate just as a base level. You can point to a bunch of different Pythons. You can tell it which one to use for each script. So you can have whatever you want installed. The first one is the Reticulate Python environment variable. If you have an R profile at any level, all the way down to the project level, you could set the Reticulate Python for that if you wanted to use it there. Or you can set it using the use Python command at the beginning of your script. If you're using a virtual environment and you have a venv file, you can use that. You can also use the Conda version of virtual environments, which is just the Conda environment. And Reticulate can use all of this depending on what you want to do with it, depending on which Python version you want it to point to, or as Mike said, maybe you have a validated version for your statistical stuff and then you have a less restrained version for building things like tools like this. So you can have different ones installed on different places and you can just point to which one you need to use. You do need, well, you don't have to do this. It will just default to your basic version of Python that you have, but sometimes that's not really, in today's case, that's not the one we want to use. We want to use this mini Conda version that we have that has Pandas in it, because not everyone has Pandas installed in it. So we have a nice mini Conda of 3.8. We just wanted to point out Reticulate's very flexible. You can really use it to kind of connect to Python how you want, on what terms you want it to, whether it's just connecting to the executable, it'll work there, virtual environments, Conda, and the Reticulate Python will take any path as well. So it's just the same thing to work with that. It's just set at a different level. So it's really easy to do this stuff in Python and R. You have to, one, of course, set up Reticulate. How else is it going to know where it's looking? Reticulate needs to know what it's looking for. And then this is for Markdown. So in Markdown, if you're starting a code block for R, you do the 3 backticks, and then you have R. You just change it to Python. If you want to do Python, that's it. You can just go coding like you would in Python. You have to keep your white space indentations correct, because Python is a white space language. tab delimited. So that will need to be double checked on your part, but it's really all already there. We'll talk more about the pass through between Python and R, but that's all you have to do to get started, making a Python code block in an R Markdown file. So a couple important things. One of the biggest things that I think is, this is R Markdown in general, is your sessions are going to stay open from the beginning of the document to the end. So if you import libraries, you only have to import them once. Your variables will stay there no matter which language you're using or where in the code blocks you are. So that's kind of nice. You don't have to re-import every time you want to use the OS library or a Pandas library. So all of that will still be there. And then you can access your variables from Python and R. You can access your R variables in Python. You just have to use the syntax. So when you're going from Python to R, you can set something in Python. And then if you want to reference it in R, it's the Py object, and then the $sign will lead you to the variable. So whatever your variable name was in Python, you just put after the $sign, and it'll grab that from Python and interpret it as well. So if it's like a true false, it'll interpret it like a true false. If it's a string, a data frame. So those are kind of the three we touch here. And then you can also go the other way. R variables can be used in Python. So if you grab something in R and you wanted to use it in Python, it's very easy to do that. I believe it's just a dot syntax on an R dot. So there's an R object in Python and there's a Py object in R that you can pass them back and forth between the two languages so that you can use what you want when you want in what use case you want to use it in.
All right, so with that, we can move on to Breakout 1. But right before we set that out, I want to explain some things that we've set up for you. We understand that there are a lot of different levels of experience here, so we've tried to give you options depending on how experienced you are with any or with either of these languages. So we have an answer key. So these are our solutions to all sections. And if you have no Python experience, or if you have no R experience or R Markdown experience, this is a good document for you to learn from. We've packed it full of comments to try to explain what's going on, to talk through the code, and show you what's being done and how. So the answer key document is available. I'll show you where these are within the file system momentarily. We also have a guided document. So this is starter code and hints. If you only have a little Python experience, only have a little R experience, this will get you started. And then we have different sections where we say your code here, and you can provide the answers. You can do some coding of yourself and complete the document like an assignment. And so that gives you something so that you're doing a little work, but it's not totally complete for you and you're not starting from scratch. But then also we know that there's still some advanced users here. So we have a blank document that we've really wiped out most of the code in there and only just left instructions for what you need to produce. So this has no starter code. You can do things your own way, and you can just take the concepts that we're going over here and do whatever you want. We've provided the goals for you, but you're free to do as you please in there. So just to show you in here, so within the Files tab, we have Validation Report Answer Key, Validation Report Guided, and Validation Report Template. So that's the answer key, the starter document, and then the template that you just have free range over. So those three documents are available for you. And just to note, there's a lot of ways to do things. What we present is just one way to do things. There's Python and R, but it's very flexible languages, so we're just trying to demonstrate different concepts. So you might not like our code, you might not like the way that we're showing it, but we're just showing you different concepts and how to do it. So with that, the challenges of Breakout 1. So this is just the start of the document. We've set Reticulate up for you, and we've imported all the necessary packages. Hopefully your installation scripts are done at this point. If you've had any problems with that, please reach out into the chat. But the goals of this first breakout, and we've broken them into blocks. So you're going to have a comment that says start Breakout 1 and a comment that says end Breakout 1. So within that section of the document, you're going to report the run date and time and user. You can use R or Python. You can do a lot of this in either language, but we're trying to show you handoffs between the two. So whatever language your preference. You're going to store the absolute paths to the programs and the outputs and the metadata directories in Python. So here within the file pane, you can see that we have a metadata directory, the outputs directory, and the programs. So you're going to want to report in the document the absolute paths, which means the full file path of those directories. And you're going to do that using Python. And then you're going to report each of these paths in line in bold markdown text. So again, if this doesn't make sense, we have the answer key. We have the guided document that's going to show you basically how to do it and then let you fill out pieces yourself. So don't feel too intimidated. But those are the 3 goals that we want you to do within this section. So we're going to go into the breakout. This first one's going to be 15 minutes, and then we're going to bring everyone back and move on with the presentation. So one of the Phil or anyone else who can help us get this set up, I was thinking, can we randomly assign to groups of 10?
Yes, for the breakout.
Yeah.
Yeah, you can. It kind of depending on the numbers and how many people you want to be in each throughout. But yeah, you can. If you just click on Zoom, there's a button there that should give you as the administrator the breakout option.
So I'm going to break into 6 rooms automatically. 9
Yep.
10. Okay. Create rooms. All right.
And then what you can do if attendees can either, they optionally can join or not join. And then Mike, what you and your team can do is like float around to different breakout sessions if you want, just to make sure things are going well, but totally up to you. Yep.
All right. So, and again, there should be an option to raise your hand. If you guys have any issues, either raise your hand, submit it in the chat. And all right, so I'm going to split this out. We're going to have 15 minutes and then we're going to regroup. So rooms are created. I'm going to open all rooms. So there should be an invite. All right, so this should have pulled everyone back. So there were some notes that I think that are worth talking about that came up as some questions. So one thing was that if you are trying to run the full report in something like the validation report guided or the template, those aren't going to knit at the moment. The knit is going to try to execute the entire file and it's going to hit errors for you. So at the moment, you can run your code blocks or another suggestion that someone has was that you can start a new file, a new Markdown file just by going to File, New File, or Markdown, and then copying all of the text to the pieces that you're working on. And then you'll be able to knit within what you've completed so far and keep building the file as you go. So if you want to knit the document and see how you're doing, that's probably your best solution at the moment. Another thing is that within the Python code blocks, typically when you're working with R, you can come in and you can hit Control-Enter and just run the line, and it will execute within the console. But that's not going to work within the Python code blocks. But for the Python code blocks, if you just hit the play button here, you will get the output of the block that you're working on, anything that outputs there, and that'll show below here. So if you're trying to see your progress as you go, just keep those 2 things in mind. And just another thing, when we go into these breakout rooms, it's if anyone wants to, if you have an experienced user, it might help if you step up, share your screen, and help anyone through with the questions that they have. We do want this to be a collaborative environment, so if you're a little bit more outgoing and you want to step up and try to talk with people and get people conversing, this is an opportunity to learn from everyone else. And I know that a lot of you here do have some good experience, so a lot of people might have a lot that you can teach and a lot that they can learn from you. So moving on, we're going to go into section 2. I know that a lot of people probably didn't finish up Breakout 1, but we do want to keep moving. And this is all hosted on our Studio Cloud. You'll be able to get back to your projects, and the GitHub repository is going to stay up. So you'll be able to access all of this as we go forward. So if you feel like you haven't been able to complete what you're doing, no worries. This will all persist after the workshop as well. So section 2, we're going to talk through some more Python stuff. We're going to go over the OS module a little bit. We're going to talk about Pandas, not the animal, the Python library, and we're going to go over list comprehensions, which is one of my favorite things in Python. So with this, I'm going to let Nathan talk and teach you a little bit more.
So operating system interaction is probably one of the more, I mean, it's different programmers, it's going to be different base steps, but operating system interaction, I think, is one of the cooler parts of Python. It's one of like the base parts of Python as well. The OS module is fairly powerful. It can do a lot of different things. We're going to touch on a few here, some of the more basic ones that it can do, but it's also, my favorite part about it is it's system agnostic. So say you get a bunch of Windows users and you dev on Linux, it'll join paths perfectly fine without you having to try to have a little character in the middle that changes depending on the OS they're using. So OS it's system agnostic, it's system aware as well. So it knows what operating system you're in and how to work with that one to get things to work correctly with, I mean, mainly file paths is what we're going to talk about now. So the three main functions we're going to talk about of it is kind of the first one's OS path join, which is actually the middle one on the slide. So OS path join does exactly what you think it does. It takes an OS path and it joins two components with the delimiter in the middle is going to be whatever the system delimiter is. So / / whatever it is, depending on whatever your system is, it will join two things correctly and store it as an OS path object, which is awesome because that is, once again, system agnostic. You don't have to be translating, / between two different things. And then OS path exists, once again, does exactly what you think it would. If you pass it a file path, it will check if it exists and return back true or false. So that's really cool if you're just trying to check, hey, does this file exist here? Yes or no. If that's all you need to know, OS path exists is exactly what you need. It'll, as I said, turn out true or false, and that's great if you're trying to check, as I said, file, program, output, metadata, whatever you're trying to check, wherever you're trying to check it, OS path exists can tell you if it's there. Now the last one is os.listdir, which lists a directory. So it'll tell you all the files in a directory, including their extension. So if you have R files, RTF files, XLSX, CSV, whatever types of files you have in any directory, it'll throw you back a list, an actual list object in Python. It'll show you back the list, and it'll basically give you access to that. You can do with that what you please, but basically, it just lists back how many, like what files are there. You can then count that list to see how many files are there, subset it based on file type. Say you just want R files, like we're going to want in a little bit. You can subset it based on if it contains .r. So these are kind of the three we're going to start out with. As I said, OS module can do a ton more things, and this is a very limited scope of what we're looking at today. But these are kind of the three that we're going to look at that are going to help us through the stuff that we need to look at today. Okay, next slide, Mike. Thank you. All right. Pandas. So Pandas, even though we have the animal on the screen, is probably one of the more powerful modules and kind of if you've heard about Python and you've heard about Python and data science, you've probably heard about the Pandas library. It's great, it's flexible, it's really powerful. It can do a lot of different stuff from simply reading things to manipulating any type of data. It can even scrape an HTML page if you really wanted it to. It can do a lot of stuff. So it's got a very powerful data reader that can read a lot of different stuff. So basically read _ thing. File type is kind of how it's going to look. You can look at the documentation on their website, but today we're going to be using read_CSV because we're going to be reading a CSV document, but it'll read all sorts of different data types. And it's very similar to the read_R interface in R. And then to go on a little bit more, it can interface, as I said, with a lot of different data types. It can do text-based stuff. It can do Excel. It can connect to a database and actually read through a database connection. As I said, one of the crazier things, it can scrape a web page for you. They have a built-in one, but it can do a lot of different stuff. So kind of the syntax for a read function there, read_CSV, and then you just put the file path wherever you're doing. If it lives on a URL, you can put the URL that it lives on and it'll read through there as well. But today we're going to be working in this local directory. The CSV we're working with is already there. You just got to figure out where we hit it. Not very well. But these are kind of the main things that we're going to talk about currently with Pandas. We're going to talk about it a lot more as this session goes on, because there's a lot of different stuff we can do with it. But this is the base stuff that we're looking at right now. Let's see, I think we got more Pandas next.
Yeah, and I do want to highlight the CSV reader is something that's surprisingly not trivial. CSV isn't a rigorous standard, and both Python and R do this very, very well in a way that it masks a lot of the complexity. If you think about it, you can have data in a CSV file that has commas by itself. This is something that I even noticed SAS struggle with in the past, and both Python and R have put a lot of work into having very robust CSV file readers. So just another thing to highlight about Pandas.
Also with read CSV, one thing I want to throw in there is it has a separator function. So say you have a pipe delimited or like a slash delimited file, whatever your delimiter is, it can take it in as a separator and it'll split on that delimiter. I think it's really cool. I've worked with a lot of pipe delimited files. It's really nice to be able to use that.
Right. If you're coming from the R world, dots are relevant in Python in a way that they're not as relevant in R. R can have dots in a variable name, and it doesn't necessarily mean anything. If you're following S3 conventions, you know that you shouldn't really use dots in your variable names. But dots in Python are relatively equivalent to the $sign in R, where you're accessing an attribute or some other objects that is a child of the object that you're working with. So in a list in R, if you have named elements, or if in a data frame, you can access that variable using $. In Pandas, if you want to access a variable within a data frame, you can use a dot if it's a name that doesn't have a space in it or any special characters. And in general, working with objects in Python, you can access attributes or methods within that object using dot, very similar to how $, works in R. So just something that I wanted to highlight here at the moment. So data frame basics. So I have up here some comparisons between R data frames and Python. So to get your column names, there's the names function in R, which is a generic, and you're able to access the names of the whatever object. So df here would be our data frame. In Python, if you want to see the column names, you can do df.columns. Extracting a column is fairly similar between the two languages, but there's some nuanced differences. So here, if you use 2 brackets in R, that'll give you the array under within the column back to you. In Python, that will give you back a series instead of a data frame. So in Python, so in R, you have arrays that sit within the data frame, or it could be lists, whatever object sits within the data frame to make up that column. In Python, they're called series, and those series are going to have a type attached to it. And then to get that series back directly, the double brackets in R are equivalent to the $sign to access a variable. In Python, you can do the same with the dot. You can access multiple columns. So brackets in Python generally return back to you a list by default. So to get back a set of columns within a data frame, you can use the single brackets and then a list of character vectors, or a list of character or strings that will give you back the variables that you want. And then in the same sense, you can create a character array in R and that use that to grab whatever columns you want. And then really we're just going on here because there's a lot of different ways to index, and I didn't even cover all of them. If you want to get a set of rows and then columns in R, you can give the row index, or you could give a Boolean array. And then in the second element, you give a character vector. In Python, there's a couple different ways to do that. You can do the loc function, and that has a similar interface to, or a loc method, sorry, and that gives a similar interface to R with the rows and then the columns, or you can grab the columns and then use iloc to get the rows. So if you look up indexing for Pandas data frames, there's a lot of ways to do it. There's plenty of documentation out there that shows how to walk through it, but these are some, we wanted to give you some kind of back-to-back comparisons, some of the standard indexing that you'd want to do. And then you have this table for reference for how you can do that in the future. So applying operations on a data frame, there's a lot of ways to do this as well. And one of the things, especially coming from the SAS world, I grew up a SAS programmer and that was my first language. So when I got into R and I got into Python, the whole fact that most languages like to do column operations but for row operations really tripped me up. So if you're doing, in this workshop, we've shown you all of the examples using iteros, which is the fourth row of this table. And that's like you're executing a for loop over the data frame, and then you can do all of your operations within a block. And then if you're coming from the SAS world, that's probably going to feel very natural to you because you can work over and you're iterating through the row and you have access to all of the variables within that row. Another way to do that would be the data frame dot apply. So in Python, that would be your variable name, that's your data frame, dot apply, and then you give some sort of function. You can pass the function in if it's already been named before, or you can use lambda functions. Lambda functions are a very powerful thing in Python and other languages as well, but I have a link in the slides to the documentation. If you're going to be doing a lot in Pandas, I highly recommend that you learn lambda functions. As they work extremely well in the applies that I have here or the assigned, but that's something that you'd want to look up. But if you're doing a data frame.apply on the data frame, you need to specify if you're going to go across columns or if you're going to go across rows. If you're trying to do, a lot of times you're going to use that axis equals 1 argument to go across the rows. A way to avoid working with your axis, and if you just have a single variable that you want to pass your operation through on that variable, you can do a series.apply, which would mean that you index the variable first and get that variable. So it could be data frame dot variable name dot apply, and then you can carry out that action and apply a function across the column. Another nice feature that they have is the assign argument, and what's unique about this is if you're using applies, you need to have a column name that you're setting within the data frame. For either a series.apply or a data frame.apply, you have to tie it back to a variable name. Data frame.assign, you can create the variable names all in one block within the function. And then you can have variable name equals, and then the function that you're executing that would create that variable. As I mentioned, iteros is like you can use it in a for loop context over the data frame. So in there you can set variables within the row that you're assigning back to. This is very similar in concept to the data step. And then if you want to set those variable names within the iteros, then the .at method allows you to specify the index and the variable name that you're setting while you're iterating through that for loop using something like iteros. And iteros is going to give you back two things, the index and the row object. So you're going to have a list that contains the rows in there. And then as you iterate through with all the column names. Nathan, anything that you'd like to add to that?
One thing we haven't mentioned yet, R is a 1-indexed function and Python is a 0-indexed function. So if you're thinking about the first element in anything, data frame, list, series, dictionary, in R you would be index 1, Python you're index 0. This is one of the first things you learn about a new language is what index did they use to begin. world at. So I just wanted to point that out real quick.
Yes, I do have that on another slide in here, but
I
that's a good point
remember
that we should bring that up now. All right, and then Nathan, if you could talk about list comprehensions.
So list comprehensions, you could probably technically do a lot of the stuff in Pandas just using list comprehensions. Basically, it's a similar concept to lapply if you're coming from R. If you're coming from neither, we're really just doing an operation on a part of a list. So in lapply and R, it's an abstraction of a for loop, carry out some action on an iterable, and the return results is a list. Similar thing in Python, it basically is just an action on an element of a list. So you're basically taking a list, putting it in there, and iterating upon that through every element and doing the same thing to every element. You can write if statements in it, so you don't have to technically do every element. You can do a lot of stuff in it. So what is an iterable? An iterable is basically anything you can iterate over. This sounds kind of interesting. Capable of returning one of its members at a time. So like a list, technically a dictionary. You can iterate over a Pandas series. So say you wanted to iterate over a column in a data frame. That's great. If you want to iterate over a tuple that you're getting back from anything, tuple can be just about anything in Python. So you want to iterate over a tuple and do something to the same stuff. So kind of the basics of list comprehension are when you're creating a new variable, this will be a new list as well. So you want a function for the element in that iterable. You can add on to this using if statements. So you can subset the iterable if you wanted, and it'll only grab in things that meet that. But kind of the basic that you're looking at here is kind of function for element in iterable, and the function, of course, is going to be applied to the element. You can go really crazy with these, and you could do a lot of stuff. And they're one of the more powerful things in Python, in my opinion, because they're really flexible and easy to use. There's also dictionary comprehensions that do a similar thing with key value pairs, but we're going to talk about list comprehensions because we're going to talk about lists and series today.
Yeah, and just realistically, the only difference between a list comprehension or a dictionary comprehension, or you can even do tuples or sets, it's going to be the brackets that use around it. So Python, the brackets are going to return to you a list. If you replace that with parentheses, it will return a tuple. And the difference between a list and a tuple is that a list is mutable and a tuple is immutable. I'm not going to get into the technical aspects of that right now because I'm already probably overwhelming a lot of you. And then dictionaries are going to be, the difference between a dictionary and a set is a dictionary has a key value pair, and then a set is just going to be a single element, and those will use curly brackets. So it's a nice feature in that these comprehensions work with different data types that you can easily return just by changing the brackets that you're wrapping all of this in. So that brings us to starting Breakout 2. And as we go through this, I do realize that some of this might be overwhelming to newcomers to Python. And just from what you take away from this, if you can just get the keywords out of what we're in the concepts of what we're trying to go over with some of these things, that'll leave you enough to access the wealth of material on Google out there when you're trying to do these things. So if you can take that away from it, it's value of itself. So Breakout 2 challenges. So now we're heading on after we've gotten the setup done. In the first block, we're going to gather names of files in the programs and outputs folders. I'm going back to the OS portions that Nathan covered earlier. We're going to read in the metadata file, and the path is metadata/metadata.csv. We're going to read that into Pandas. You're going to, and I want you guys to review the file and familiarize yourself with with its contents. So a question there is going to be, how do you do that? So I'm going to cheat a little bit and just show you that if we run this block here, you go to your console, fun. Because I haven't run any setup in this Markdown document. Excuse me. I'll just run all the blocks above it too. So here, and now that block is good. You're able to look inside this and see the data that we have available. So review the metadata data set, and then Nathan talked earlier about accessing variables within the Python environment in Reticulate. So you can do py, and then $, and then the Python variable that you want to access. And in here, you're able to view that in the dataset contents. But I'd like you to explore yourself and that for yourself and familiarize yourself with the data that's available in the metadata CSV file, or you can read it in R and just familiar with the content, whatever is more accessible to you. And then we're going to bidirectionally check the metadata directories for programs and outputs. So what does bidirectional mean? We want to see if there's programs in the metadata that aren't in the directory, programs directory, or if there's programs in the, and vice versa. So if there's programs in the directory that aren't in the metadata. So that for the programs in the outputs folder, and then you're going to create Boolean variables. So that's logical, true or false, for if there are any programs missing, if there are programs in the folder not in the metadata, if there are any outputs missing, and then any outputs in the folder not in the metadata. So for that, we want you to do it all within one Python code block, and we're going to gather information here that we can report in the next section. So again, we have the guided file, we have the answer key. If you're struggling, you can take pieces from the answer key to move on to the next section or what have you. So if you need any help, reach out to us and we can jump into the room and we'll be floating around again. So with that, I'm going to put you back in the breakout rooms. Nathan, anything you want to add before we jump in?
I don't think so. Good luck, guys. This is a lot of the cool stuff that we're going to do. This is the start of the really cool stuff. Everything else is just operating system. This is where it gets real fun.
All right, so I'm going to open up the rooms again. If you have any issues, reach out. All right, so we should all be back in here. I'll get the slide deck going again. One of the things, or two things came up in that last breakout that are worth mentioning. I'll actually stop this. If you are creating a separate Markdown document to build on the sections as you go along, remember to take the content from everything above that section. When you try to knit a Markdown document, it's going to run a fresh session. So it's going to need all the content from above in the breakouts 1 and 2 and all that setup code. So just make sure that if you just want to focus on, let's say we're going to move on to section 3 here, you want to take from just like the answer key and bring it down sections 1 and 2. Also, if you see things are getting hung up, then check out the console. We had some instances of people's sessions saying, having Reticulate ask if you wanted to install Miniconda. That was causing some problems. So it looks like the easiest solution is to just restart R. And if you're an R user, a really helpful keyboard shortcut is Control-Shift-F10 or Command-Shift-F10 for you Mac users out there. Or just on the Session tab, click Restart R. So those were two problems we came across. If they pop up for you, if you notice your session hanging, check out the console and just make sure that if you're working through a new document, you have all the content up from top to bottom. With that, I'm still sharing my screen, right? Nope. I guess I never started.
Nope. I was about to say, it's just your face.
Which is
It's
perfectly
terrible.
pleasant for all of you, but okay. Thanks, Nathan.
That's all right.
Section 3, so conditional text, conditional code, and handoffs. So we're going to talk about some conditional markdown text, conditional code, executing code blocks based on variables in your environment, and handoffs of data between R and Python. So Nathan, I'll hand it over to you.
Yeah, so when talking about this workshop, one of the coolest things that I saw about R Markdown, I'm also a SAS user from the beginning, so I started in SAS. I did Python and R before that, very briefly. My first real coding language was SAS, and then I came back, learned a bunch of Python, and then when I came to Atorus, I learned a bunch more R. I dabbled in it before, worked on a bunch of stuff, well, more than dabbled, but I worked on a bunch of stuff. I never really touched R Markdown, and when I got to R Markdown, one of the cool things about it is that you could do stuff conditionally. And I thought that was really cool, that you could actually like conditionally execute stuff, code blocks. There's a lot of different pieces to R Markdown, more than just like writing out a couple of things. So we already covered that you can reference Python variables using Python py and a $, which will let you reference anything that you have in your Python session, from data frames to Boolean, true, false things, strings. If it can be interpolated, it can be changed from one to the other. So inline, you can do R Markdown text. It's not just text. You can put more than just strings in there. You can see we've put a bunch of comments. Those use the same syntax as HTML. So comments can be put in there, but you can also do inline code. You can write entire R blocks inline if you really wanted to. You just have to start with backtick and R and end with backtick. You can write conditional statements. So below that, we have conditional inline. So basically, that is going to conditionally write something inline. So it's an R code block with an if condition. So if you put, is something true in that if, so if you put a true false variable in there, it's only going to write out what's in the brackets if that thing is true. So if that condition that you gave it is true, it's the only time it's going to write that out. If it's false, it's not going to write that out. If you only wanted to write it out when it's false, the syntax for R for false is just the exclamation point followed by the variable. So if you wanted to do the opposite, you can say if, and then instead of condition in there, you can do exclamation point condition, and it'll only do it when the condition is false. So the nice logical inline stuff is cool if you're just trying to write a few sentences, write a paragraph if something's there. In this case, like in our case, if everything's already there, we kind of want to tell the user, well, everything's already there. All the programs are already there. If something's not there, we want to start, some programs aren't there. You don't just want to have like them to try to deduce that. It's really easy with the Booleans we've created to be able, and for those of you who don't know, Boolean is just a true false variable. It's just a bool. So using those, we can conditionally write whether everything's there, whether it's not there. We can conditionally do that inline. You can use conditionals on a lot of different stuff, which we'll talk about in a minute. But this is just conditionals inline. It's really simple. You just start with R, and then you do your if condition, and then in curly brackets, you put what you want written out if it's true. So if that part is true, you write this part out. That's kind of how they work in there. So I want to talk a little bit more. Alternatively, you can do it in a code block. So say you wanted to do a bunch of stuff and then like actually output the last part. So you could do this all in a code block using if-else conditions in R. So say you didn't want to do inline necessarily, you could use this kind of code block statement. The results equal as is. So normally, if you just did this without the results part, this is like the key part of it. If you just did this without the results part, it would print it out like it was printing out code and printing out comments. And it wouldn't look, like clean, like it was supposed to be there. It would look like it was code and it was stuff coming out of code. Normally, not just written sentences. The results equals as is basically tells it, present this like you would see it if it was a text string or if it was whatever you're trying to put out there. And the cat, not print, we'll print it, we'll kind of print it out nicely. We'll put it out there nicely to be able to see it. Okay. Conditional code block evaluation. So this is one of the other cool things. If you don't just want to do text strings, if you want to do more, we're going to cable out some data frames here. It's going to be great. So conditional code blocks, there's a bunch of options for code blocks. Echo is kind of the main one that tells you if you want to include the code in the output document. All of our stuff's going to be echo or include or echo equals false, so it doesn't actually put it in the output document because you don't necessarily want a bunch of random lines of code in something you're trying to print out as a validation document. But the one we're going to look at right now is the eval option. So the eval option takes true or false. So what eval is it's simply, should I execute this block? So when the knitter gets to that block, it's going to look, if it doesn't have an eval option, it's just going to be true. It's just going to eval everything. But if it does have an eval option, it's going to check, is that variable true or is that variable false? If the variable's true, it's going to execute that code block and do whatever else you have in there. If it's false, it's just going to keep going. It's just going to forget that happened, skip over it. And this can be used in a couple of places. You know, say you, for efficiency's sake, don't want to run all your code unless, you know, certain conditions are met. You could do that. Or in our case, we're going to use it to display things if a condition is true. So it's great for kind of displaying stuff when you want and not having random blank space or random empty data frames out there when you don't want it. But it's just a really kind of cool thing that can help clean up your output. Your code's, of course, still going to have all that code in there, but your output could not end up having it. So in this example we have down here, so say you want to output a data frame, but you don't necessarily want that just to show up if there's nothing in that. So say there's no rows in your data frame, you don't want that to show up. So this eval is going to check if the number of rows in the data frame is greater than 0. If it's greater than 0, we're going to use this cool cable function, which really just nicely outputs a data frame in R. It's an R package. There's cable extra, which does styling as well that we use a little bit. But cable is kind of the base one. And so this one's just going to say, if I got more than 0 rows in my data frame, I want to cable this out. I want to print it out nicely in my output. I think that's it for that. Yeah. Breakout 3.
So now we're going to move on to the third section. As a reminder, if you haven't caught up, you can take the answer key and start a new file and then use that, all of the answers down to section 3. And then you'll have all the completed pieces. So in this section, we're going to do some conditional text. And if you look at like the example validation report.pdf file that we have in the directory, you'll see some of what the report is actually producing here. But we're going to write different text, write different lines in the PDF file, depending on if some or no programs are missing, if some or no programs were present in the folder that aren't in the metadata, if some or no outputs are missing, if some or no outputs are present in the folder, not in the metadata. And then you're going to create code blocks to output the detailed issues in a nicely presented table, only if the problems exist. So here, where cable does all of that footwork for you and you have the data frames, but what we're going to want to see is you're only going to produce that table if a problem existed. And if you look back through the prior sections, we were creating those logical Boolean true-false variables. So you're going to use those to trigger if those code blocks execute. So we're going to do this one for 20 minutes again. If you have any issues, raise your hand in the room or reach out to one of the hosts. So with that, we're back into the breakout rooms and we'll see you all there. I'm talking on mute. That's great. All right, so we're tight on time, so we're probably not going to be able to do the last breakout to its full length, but we'll give you the time that we can. But we're going to enter into section 4 here. So we're going to talk about parsing files, text searches, and filtering data. So opening files in Python. So Python can process text files, and it's really one of the powerful things that Python can do. Python parsing text is something that I heavily favor Python to R, just because of how strings work in Python and the things that you can do with it and the way that you can interface with with files. It has a really a lot of really great operations that you can do on text and string objects. So it programs, and when you're thinking about files, text files can be a lot of different things. It can be your programs that you write your files in text-based outputs like RTF. It doesn't have to be data structures like CSV or tab delimited. You can really start to, when you're parsing text files, it can be any sort of just free text file that you have available. So context managers are a complicated sounding word. That's just a way that Python can handle interfacing with your file. So the with statement in Python can manage opening the file and closing the file. And this is something that it seems kind of trivial at face value, where you open up the file, you do some things, and then you also need to tell Python to close the file so that you're done working with it, and that, for instance, on the system, there's no lock file put on it to prevent anyone else from editing it. So with will handle all that for you, and it can it'll automatically close the file if you hit an error in that loop, which could leave Python with the file open if you don't use that context manager. So that might sound confusing, but really the syntax is quite easy. So if you want to open up a file, you can do with open, and then the file name, and then that second parameter is just the access that you're using for it. Are you writing? Are you reading? And then there's ways to control if you're opening it as binary, or if you're controlling the encoding, if you're using UTF-8 versus Latin 1. So there's other settings on open if you look into opening text files with Python in more detail. But then as F, so F is now going to be the object name that holds the file. If you want to get the text out of the file, you can do text.read or f.read and store that into a variable. If you want to have all of the lines of the file as a list, you can do f.read lines, and then it gives you a list of every line in the file. And then you can have other code that operates on that file. And then at the end of the block, when you go back and remember Python indentation matters, white space is relevant. So that's something that you'll need to get used to between Python and R. But once you get out of that indentation block, the file is closed. And if you hit any errors within that block, the file is automatically closed for you. So searching for text within, searching text for a substring. Python has a lot of different methods available to search a string for a substring. And there's other things available besides what I have on the screen here. Strings have a lot of different methods available to them in general. And I think Python 3.8 adds even more to that, or there are some newer features to check, like that a file ends with something. So if you have this, if the text is stored in a variable, let's call it text variable, one thing that you can do is .find and then looking for the substring. So that's going to return the index of the substring within the string, and if it's not found, it's going to return -1. So this is something you got to get used to in Python versus R. Again, here's my note that Python uses zero-based indexing. 0 is actually the first character in the string. So if the string starts with the substring, then it's going to return 0. It's going to be the first character within the substring found within the overarching, or within the string that it's contained in. Another thing that you can just use is the in operator. So you can do substring in and then the text variable, and that's going to return true or false if the substring exists in the string, but it's not case sensitive. So if you want to do case sensitive searches, this isn't a method that's not going to work for you, but it's convenient if the case sensitivity or it is case sensitive. Sorry, if you want to do case insensitive, then it'll work the other way. So that's a correction I got to make in the slides for clarity. And then if you want to get into advanced text searching, you can use regular expressions. R has its own, R has regular expressions as well. One of the things that's annoying before raw strings exist in version 4 of R is that you need to use double backslashes, and that can make your regexes even nastier. But Python does have a good regex engine in it. And so here, if you just want to get a search object back, you can do re.search and then substring, comma, and then the text variable that you want to search. So this can do flexible searching. You can use regular expressions if you're not familiar with them. They are very scary to approach at first, but they're very, very powerful. And that's going to return an re.match object, which isn't necessarily clear itself because it's going to contain data about the span where the string starts within the substring, where it ends, so on and so forth. But it can be coerced to a Boolean, so you can actually just wrap that in bool to create a Boolean object, which is just true or false, and then that will tell you true or false if the string, if the substring was contained in the string. So this is a little bit more of a robust and flexible method to get used to that can give you some more power behind your searches and some more flexibility. So subsetting data frames in Python. This is something that R, if you're familiar with tidyverse, filter makes this really easy. So there are a few different ways that you can do this, but in the first way is you can pass a logical vector. If you've already done a check for the rows that you want and you get a vector of true and falses, then you can just pass that vector in and it will give you back just the rows that you're looking for, the rows that are marked true. But that can also be logic. So you can do something like if you have a numeric vector in df.x, so the x variable within df, you can do things like greater than 5, and then you'll get only rows that are greater than 5, because what df.x greater than 5 actually returns is a logical vector. But then you can also use, if you want to do compound operations for OR, you can use the bar symbol, and for AND, you can use the ampersand. So if you surround each of these conditions in parentheses, then you can build up these compound expressions. So here we have the variable x greater than 5, and df, the variable y, is not NA. Within Pandas, there's a number of methods that are available to do some particular checks. It's a very powerful library, so there's a lot to that. And that's something that's worth looking up. But here, if I wanted to find records where the x variable is greater than 5 and the y variable is not NA, I can surround both of those in parentheses and use the AND, or the ampersand, and then I will get records from df matching that expression. So from there, and then just another thing, we're trying to get the best of both worlds of these languages. You could also pass the data frame from Python back into R and use tidyverse and use dplyr to filter the data frame instead. So if you're a Python programmer and you don't know R, you can do your subsetting directly in Python. But if you're an R programmer and you have the data frame available in Python, you can just pull it back into R and use filter from dplyr and get it just as easily. So that's another beautiful thing about Reticulate, and we'll have some demonstrations of that in section 4. So we're at about 4:40. The breakout or the workshop is scheduled to end at 5. So we're only going to keep this one at 15 minutes. And so looking at the breakout 4 challenges, this is actually supposed to be breakout 4 challenges. So this last breakout, what we're going to do is try to tie some concepts together. So we're going to pass over the metadata data set from before, the one that we created before, and check if the source file name is in the output file. So you're actually going to open up the output file, which is an RTF file, and RTF is flat text. So you'll be able to parse that text, and you're going to search it for the name of the source file that was supposed to create that output file. So just again, tying this back, typically when you create tables, you might have a footnote that tells you the path of the file that executed that output. So you're going to search the output file to look for that source file. You're going to create a new data frame of records, of just records where the output is in both the metadata and the outputs directory. So you're going to filter down that data set. You're going to create a variable that's true if all the source file names are in their output and false if not. So that's an overarching Boolean. And again, we're going to use that to trigger whether or not the report or the table is presented at the end. And then we're going to create a section that dynamically tells us if something is wrong and outputs issues in a nicely presented data frame. So this one's a little harder. Do what you can and reference the guided file or the answer key for help. And we're trying to tie in a few more concepts here. So with that, I'm going to put you back into the breakout rooms, and we're going to come back a little earlier. If you don't finish, again, this content's going to stay up, and you're able to take this home and work on it later. So back to the breakout rooms. Good luck, everyone. All right, so we're getting towards the end here, so I really just wanted to bring everyone back in and do some last wrap up. So I really just have a few points that I want to close on. We wanted to show you today that Python and R can play nice together, and that you can use them within the same document. We thought this was a cool application to show how you can use some of the features that Nathan and I both really enjoy about Python, you can tie that in with R Markdown and leverage the Markdown engine that R has to create these reports. There's a lot more that Reticulate can do, and Phil talks a good bit about that earlier, but Reticulate really allows Python and R to talk quite nicely. If you get into things like modeling and using some of those more advanced objects, it packs even more power. But even in this simple context, it can do a lot for you to let you create really awesome reports and leverage the best of both languages. And just in other contexts, when you have a multilingual team, if you have people who favor Python, people who favor R, it lets those programmers who favor either language work in the language that they choose, and work together so that you can really get the most out of it, and allow those programmers to talk in other ways that they otherwise might not be able to do as easily. And you can create awesome reports shockingly easily in R Markdown, and even getting into Shiny using the best of both these tools. So I hope that you can take away something from this today. We thought this was a nice application that maybe you guys could take home and use within your own companies. If you have these things on the system, even in an unvalidated context, there's a lot that it can do for you to allow you to create these reports. And you can really expand out where this application can go into whatever you want to check, just with what you can do in Python, what you can do in R. To really build out these reports. So there's a lot of different applications. This was a subset that we thought that we could cover well in 3 hours. We're not going to teach you everything, but we hope that you can take some away from it. Phil, do you have anything that you want to wrap up on either?
Yeah, no, one thing I was just showing my group that I'll just add into the chat box for the group if people find this interesting is that in the data science space, what's really popular is like your Python programmers, right? They may have a Python file that trains a model or does some type of computing. And as an R user, you want that, right? And so what's popular in this space, and to take it to the next step, is that then they'll use a package called Plumber, which lets you create R-based APIs. And then you can basically consume in those Plumber APIs, those different Python files, and you can just source directly Python files with that. And so in the data science space, this is really, really popular because then what they'll do is they'll deploy that Plumber API, that R-based Plumber API to their API system. And basically now you're letting the Python programmers do their thing, the R programmers can do their thing, but they're all starting to come together. And the secret sauce that's making that happen is Reticulate. And so this is a big part of the future of I would say the existing infrastructure around machine learning, and as well as I could see a future where things like this come into the more so into the pharma space. You might take a look at that example, which is not R Markdown based at all, but it takes it kind of to another level of what you can do with Reticulate. All righty.
So with that, again, you guys have the links, you have the GitHub, you have all the material from today. So if you didn't wrap up, feel free to work on it later, and you can access this all in the future as well. We're not taking down the repository, so that'll continue to be available. And if we update in the future, you'll have access to that. So thank you everyone for your time today. We really appreciate you coming out to the workshop, and I hope you all learned something.
Hey, Mike, one last thing I'll mention is that we're planning on keeping the RStudio Cloud environments up and running. So if you want to continue to play and learn about Reticulate and Python and R, feel free to use that, and you can certainly play with it. We're not planning to take it down, so it should be up. Sometimes we'll take down the environments after a day or two, but this one we're leaving up. So hopefully it's helpful, and we'll probably send a survey out in a week or two after the conference. So definitely let us know if you have any thoughts or feedback.
Absolutely. We'll really appreciate hearing that from you guys. So thank you, everyone. Have a great night, and I hope to see you all later.
See ya.
Thank you. Thank you.
Thanks.